Domain and range. When we're talking about a function, we have these words called domain and range. We also have input and output. So we give our input and our output specific names. So a domain of a function is all input values. And typically what we're talking about usually when we graph things is we have an x value and a y value. So this is all of your x values. Your range, on the other hand, is all your output values. And again, typically when we're talking graphically, you have an x and a y. So this is going to be all of your y values. We can take a look at our little picture down here. It says the domain of a function is the set of all possible input values. So if we take a look at a function, we have input going into our machine of -2. Okay, we do whatever we need to. So we have y equals 3 times x. So if our input going into the function is -2, this would be y equals 3 times -2. That's why we call it the input, because you put it into the function. Then what comes out of the function, you actually do 3 times -2, which gives you -6, which is called the output. So if this was our specific function, the domain would be the -2, or it would be part of the domain, and then the -6 would be part of the range. Another thing to start thinking of here in advance is something that we've learned before that's called the independent variable and the dependent variable. Okay, so if we're looking at it as this idea of input versus output, the output depends on what is put in. So the input is independent because it doesn't matter, it can do whatever it wants, versus the output is dependent on what is put into the function. Example 3, find the domain and range of the function represented by the graph. So if we look at letter A, our domain is going to be all of your x values or all of your input values. So I've got these dots up here. And then something I want you to focus on is this is your x-axis. Your x-axis is the horizontal one. And I'm going to look at each dot. This dot, and I should have mentioned this, when you read a graph, you read a graph like you read a book. You start on the left and you read to the right. So when you report your domain values, you start on the left and you read to the right. So our most left dot is over here, and you can kind of track it down, and it's at -2. So our first domain value is a -2. Our next one is at -1. Our next one is right here on 0. Our next one is at 1. And then our next one is at 2. So your domain, you would just tell me -2, -1, 0, 1, 2. Range. Now, range is all of your y values. So your y values are your y-axis. And when you read these, you start from the bottom and you read to the top. So when you report range values, you always want to start with the lowest to the highest. So our lowest point is down here, which is at 0. Then we come up and we actually have 2 points sitting on the same range value, which would be at 2. Now the output values, you are allowed to have multiple ones, okay? That's why it's called a vertical line test, not a horizontal line test. So in order to be a function, it only has to pass the vertical line test. So you notice nothing in the domain repeated, but in the range it will, because we have a 2 and a 2. But you only have to write it down once. Then we're going to go up further, and we're at 4. So your range is 0, 2, and 4. Now, make sure you look at that carefully, because I'm going to come back in 1 minute, okay? Example B. Take a look at this graph. Domain, range. Now, starting with the domain, that is all of our x values. So if I'm looking at x, I'm starting on the left, I'm reading to the right. So any value down here that the graph is at. Now, do you notice the big difference between this graph and the one we just did? The one we just did just had like specific points. So we listed the specific points. We said, okay, -2, -1, 0, 1, 2. This kind of graph is what we call discrete, meaning it's just a set of dots. It's discrete data. Versus this one, we're going to call continuous. It doesn't have specific dots. It's just continuous the whole way. It just keeps going, 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 going. So our domain, yeah, it starts here at 1. And yes, it's at 2, and yes, it's at 3 and 4 and 5, but it's also at 1.5, at 1.2, at 1.8, it's at 2.1. It's all of these numbers in here because it's a continuous line. So we're going to report that 2 separate ways. So the first way we're going to do it is we're going to do it in interval notation. And then after we figure out interval notation, we're going to do inequality notation. Now, when you're dealing with interval notation, I'm going to say that my domain is between 1 and 5. So that's a range of values from 1, to 5. Now, in order to report that, I can either put a bracket or I could put a parenthesis. So the question becomes, well, when I'm over here at 1, is this a closed dot or is this an open dot? Meaning, am I actually touching at 1? The answer to that is it's a closed dot. I'm touching it, so you're going to put a bracket. Same thing over here when I get to 5. And again, you're looking down at the x value. It's a closed dot, so we put a bracket. So you're telling me that your domain is any number between 1 and 5 touching at 1 and 5. Now, inequality notation, same thing, it's just going to look different. These are all of your x values. Your x values range between 1 and 5. So kind of like we did when we did solving inequalities. Then we talked about open dot or closed dot. These are both closed dots. So x has to be greater than or equal to 1 or less than or equal to 5. That's your inequality notation. Range. Now, range is all your y values. So again, we're going to start low and we're going to go high. And we're going to do both notations. So interval and then inequality. Interval notation, low to high. My graph goes the whole way down to the lowest point. It's at 0. So I'm going to start at 0. Then my graph goes up on both sides. That's my high point, to 4. And then at 0, there's not actually a dot down here, but does the graph actually go and touch the x-axis? Yes, it does. So because it's touching, we put a bracket. And then up here at 4, it has that closed dot, so we put a bracket. Inequality notation. This time you are talking about the output values or the y values. So y is between 0 and 4. And then we do y is greater than or equal to 0 and y is less than or equal to 4.